Hi guys, and welcome to Activity 7 in the Year 8 Physical Sciences course. In this video what we're going to be looking at is how to calculate the amount of energy coming into the body as well as the amount of energy going out of the body in terms of exercise or various activities. Okay, so what we've got here, one thing that we really need to be aware of is that when we do any form of calculations, this equation needs to occur, that the energy in always equals the energy out, regardless of whether the energy out is in the form that we want it. All of the energy in must equal the energy out. Okay, so first off, let's look at how we calculate how much energy is coming into the body. So in this table here, table 1, we've got a number of foods down the left-hand column, and down the right-hand column there is the energy that they give in kilojoules. Now these numbers are arbitrary, i.e. they're just made up. They don't relate to anything in reality, they're just numbers that we can use. So we can see here that an apple gives us 350 kilojoules of energy, a banana 400 kilojoules of energy, a slice of bread 350 kilojoules of energy, etc, etc. So when you're trying to calculate the energy in, what you need to do is to add together all the different types of food that you've got and add their energy values together. That way it's very easy to work out what the total amount of energy that is coming into the body is likely to be. No one's actually saying that this is definitely going to be the energy that you're going to get inside the body, but it's the potential energy that you're going to get. So let's look at the question on the right hand side here. So it says if a person was to eat the following foods in the following quantities, how much energy would they take in? So this person is taking in 2 apples, they're having a banana sandwich with a spoonful of butter, half a chocolate bar and 2 biscuits. So let's look at it. We've got 2 apples, 350. 1 banana sandwich with a spoonful of butter. So a sandwich basically is made up of 2 pieces of bread. There's 1 banana in there and there's a spoonful of butter. So what we would do is look for the banana, look for the 2 pieces of bread and the spoonful of butter. Half a chocolate bar, well, you're going to obviously have to divide the chocolate bar value by 2. And obviously 2 biscuits, you're going to have to multiply it by 2. So what we would do is we'd set out the answer that looks like this. Here we've got down the left hand side all the information that we've been given in the question, and in the right hand side there's the energy calculation. So 2 apples basically is 350 kilojoules multiplied by 2 because we've got 2 of them, so it gives us 700 kilojoules. 1 banana sandwich with a spoonful of butter. Basically you can see here we've got 2 pieces of bread at 400 plus 400 for the banana and 450 for the spoonful of butter. Add all that together, we get 1650, so that's the sandwich dealt with. We've got half a chocolate bar. Well, the chocolate bar is 1000 kilojoules, but we've only got half of it, so we've divided it by 2. That gives us 500 kilojoules. And obviously 2 biscuits, each biscuit being 550, so we multiply that by 2, that's 1100. So now we add all those values together, all the values in white, we add them all together, so that's 700 plus 1650 plus 500 plus 1100, and the total energy that is consumed is 3950 kilojoules of energy. So that's always useful to know, and by knowing that sort of energy value that comes in, you can then say, well, if I do this activity, am I going to have enough energy? The answer might be yes, or it might be no. This is quite important if you're doing things like sports science, or you want to be a dietitian and you want to make sure that the athlete that you're working with always is taking in enough energy into their body so that they can perform at their peak performance. Okay, so that looks at the energy coming in. So let's look at the energy going out. Well, in table 2 here, what you can see is we've got a table where we've got a variety of different exercises and the energy that relates to that exercise in kilojoules per minute. Notice the per minute. So obviously if you're going to be doing lots of, or that activity for a long period of time, that is the energy that you're going to be using up. Now obviously that's not going to be, this is going to be the average energy, because obviously you may change the speed or the amount of exertion that you put in when you ride a bike. For example, if you go up a hill in a high gear, you're going to use up more energy than going down the hill in a very low gear. So these are just average values. They're arbitrary again, and they're just there to give you something to work with when we do the calculations. So in this case, we're looking at the energy output, how much energy is coming out due to the activity that we do. So let's look at the question. Sally came home from school and did the following things. She did 1 hour of homework, 30 minutes of swimming, she walked the dog for 20 minutes while singing to her iPod, 8 hours sleeping, and basically we want to know how much energy she utilised doing these activities. Okay, so we go over to the answer sheet. Now basically we've got 1 hour of homework, so 1 hour of homework is 60 minutes. It takes 10 kilojoules per minute, so she used up 10 times 60, which is 600 kilojoules of energy just doing an hour of homework. That's obviously why you feel tired when you've done your homework. 30 minutes swimming. Well, swimming is 130 kilojoules of energy per minute. She did 30 minutes of it, so multiply them together, 3,900. Now this one here, where she walked the dog, we have to take into account the fact that while she was walking the dog, she was also singing, which is going to use extra energy. So what we've got here is 20 minutes of walking. Now walking is 20 kilojoules of energy. She did it for 20 minutes, so in brackets you can see we've got 20 times 20. Then she also added to that the fact that she was singing. That used 8 kilojoules of energy, and she did that for 20 minutes. Now if you put this into your calculator, make sure that you put the 20 times 20 in brackets, then hit the plus sign, then the 8 times 20 again in brackets. If you don't, what will happen is you'll have 20 times 20 plus 8 times 20, and the calculation won't work. So you must put them in brackets first. If you do all that, basically we come through with 560 joules of energy. And finally she slept for 8 hours. So we've got 8 times 60 gives us the number of minutes in 8 hours, and then it takes 6 kilojoules of energy per minute as she sleeps through, which comes out with 2,880 kilojoules of energy. So what we now do to work out the total output, we add all those values together. 600 plus 3,900 plus 560 plus 2,880 gives us a grand total of 7,940 kilojoules of energy output. Now, that's going to be useful to know, because if you know the input and you know the output, if you basically don't get the input right, you'll never have enough energy to actually do the output. So you can see that it's important that you know how much energy is coming into the body, so that you can then make sure that your exertion, the activity that you do, will counteract that. Okay, well I hope you found that useful. Do go on and look at the various exercises that we've got in this little section. There's plenty of questions that will allow you to use these energy tables for in and out, and I've made them quite complicated as well, so you're really going to have to think your way through the problems. There are worked answers at the end of the activity, so by all means go and check those and use them to revert back if you're not too sure where to go. Alright, well I hope you found that useful, and I look forward to seeing you again. Thank you for watching.